Hello everyone, I am Siddharth. I am an alumnus from IISER TVM, and today we will be solving a question that appeared in the IISER entrance exam in the year 2020. This question says that the potential energy of a point mass is given by this function. If it starts from rest at this point, then we need to find the maximum speed that it will attain during the entirety of its motion. Now, from the initial position of the object, we can substitute this x into the equation for its potential energy to get the initial value of its potential energy. And since the object had started from rest, this will also be the total energy of the object initially. And since energy is conserved, we know that throughout the entirety of its motion, the energy of the object should be equal to the initial potential energy. So if we substitute the value of x into the potential energy function, we get initial potential energy is equal to A into A upon B, that is x, plus B into A upon B, which gives us twice of A square upon B. So we need to ensure that the energy of the particle during the entirety is equal to this value of initial energy. Now, since we need to find maximum speed, we are concerned with the maximum kinetic energy that the object will attain. And we know that when the kinetic energy of the object is maximum, its potential energy will be minimum. So let's minimize this potential energy. We can minimize it by simply taking the first derivative of its potential, that's given by A plus 2 into Bx, and setting it to 0. Now, solving this equation, we get the value of x where the potential energy becomes minimum will be equal to simply minus of A upon 2b. And at this point, the minimum value of potential energy V minimum will be equal to, we can just substitute this value into the expression A times minus A by 2b plus B times A square upon 4b square, since we are squaring these terms. This term gives us minus A square upon 2b. This term gives us A square upon 4b. So we will be left with minus A square upon 4b as the minimum value of the potential energy of this particle. Now finally, we can just conserve the energy at this point. If potential energy is minimum, kinetic energy should be maximum. So we can write half into mass of the object into maximum speed attained by the object plus this value of minimum potential energy, that's equal to minus of A square upon 4b, and this is the total energy of the object which is conserved. So this should be equal to twice of A square upon 4b, twice of A square upon b, sorry, not 4b, just A square upon b. Rearrange the terms, we get twice of A square upon b plus A square upon 4b. That will be added, and we can thus find the value of its maximum speed. And so if we solve this equation for the value of V, we get it as V max is equal to 3 on top into A upon under root 2bm. Thus, option A is correct in this question. Thank you for watching this video, and please subscribe to our channel for more such content.